Hello everyone, this is the third video explaining Kubernetes and working on our application and deploy a .NET application, a Razor Page app to be more exact, into Kubernetes cluster. In the previous video we already built the application, so basically this is the application. We already looked into it, how to show to add the categories and other stuff, and then the relationship between them. We also looked into Helm. We saw that how we can create the values.yaml file, and then based on that we referred to that file in all our Kubernetes resources, and then we use the Helm install command in order to create a chart. Now in this video I'm going to show you how to create an umbrella chart. So basically this is the third scenario. In the third scenario, we started in the first video by deploying everything directly into by using Kubernetes API. So we used the resources in Kubernetes. In the second video, we deployed the second scenario in which we made two Helm charts. First, we deployed the Postgres and then the application. And in this scenario, we are going to create one Helm chart, and we put the other charts as subchart into this Helm chart. So basically we are going to have one single chart. This is called parent chart, or the umbrella chart called app stack. And then under the charts we put both Postgres and application. Now in order to be able to create such a thing, it is important to know the structure. So the previous two charts, one thing that we can do is that we just go ahead, we create a new chart, we call it app stack in this case, and then under the charts always by the way, use the Helm commands because it creates everything that you need. So basically Helm create, I have already put it in my basically in the documentation. You can use Helm create. With Helm create you can go ahead and create the umbrella chart or the parent chart. You remove the templates because here we don't need any templates ourselves, and then under charts we're going to put two subcharts, one for our application and one for our Postgres. So the stateful set goes to the Postgres one, and the application includes the deployment set and the deployment and other stuff. And then the other thing that is important is the Chart.yaml. So basically the chart of this basically parent chart is as follows. Up to this point everything is the same. As always, we have an API version, we give it a name, some description, the type again being of type application, and as I mentioned in the previous video, most of them are type application rather than library, and then we give it a version following semantic versioning, and then app version. This app version has nothing to do with this version that we are using here. So in the previous examples, for example for Postgres, I used that with you giving the Postgres version, and for my application I used the version that was for my application. And then I have dependencies. Dependencies refer to these charts that I have here. In the dependencies, I put in order what charts needs to be created. One thing to pay attention to is that the name that you put here must be the same as the name that you use in its chart. So look at the chart, for example, for Postgres, the name of the chart is Postgres. You use the same name here in your dependencies. Or for example, if you look into application, you see that the name of the chart for application is application. Then I put here application. And after that, you put the same version that you're using here for it, and then you refer to it. And now how do you refer to it? You just mention file / charts. So basically it goes under charts, and then it basically here under charts, and then it looks for application. Basically that's it. That's all in order to make the dependencies. One thing that is important that I will later talk about is the dependencies, but I will shortly get to that point. So what do I mean by dependency? I mean that this application depends on this Postgres and doesn't start unless the Postgres basically start, and only after that this one starts working. This is what I mean by dependency between them. So that's it. That is basically how we can create an umbrella chart. So basically the most important part is this part, and after that, and putting the subcharts under charts folder. We don't need the template, and then we create the charts. Then the other thing is the values.yaml. In values.yaml, so whatever charts we have, so for example here I have application chart and I have Postgres chart. I can put application and then here I can put Postgres. And one thing I can do is that whatever values that we've been using for application, I can go and put it under application. And same thing, whatever value that we've been using for Postgres, like for example config map, or for example basically secrets, persistent volume claim, etc., we can go ahead and put it under, as you see, Postgres. So whatever chart we have, they will be reflected in values YAML of the parent child. Do we have to do this? Not necessarily. We can keep all those values under the basically under the subchild or the child chart basically. So for example, or one thing we can do is that we can put some default values in the subchart values. Like for example, here I have put StatefulSet under subchart of Postgres, and then the persistent volume claim or the service and other stuff, I've put them in its parent. So what it does is that parents has priority over the subchart values.yaml, which means if you have values that are in subchart values YAML file, and you have values that are in the parent child's subchart, parent's child values, the one that are in the parent child will overwrite the values in the subchart. Also, if you have something that is in the subchart and not in the parent chart, at the end the integration of both of them are being used. Basically like this case. In this case, a stateful set values are in the subchart of Postgres, while everything else, service, secret, config map, persistent volume and persistent volume claim, are all put in the basically in the parents subchart. So that's the most important thing. And both of them are being used in order to create the Postgres basically whatever that we have there, like this, like it's a stateful set, everything else. So that's the first thing. Now that we have everything this way, so the values, the chart and the subcharts, that's it. We have one chart which includes all the child charts, and with one command we can go ahead and create the whole infrastructure. One thing that is important to pay attention to is that what we need to put under subcharts. The things that live together or have the same life cycle, they need to be put under the same chart at the same time. So for example, right now we are developing a microservice application. In microservices, each application has its own database, and no one is going to share this database with. So basically, our Razor Page application, imagine that it is a microservice. It has its own Postgres database, and its Postgres database is only being used by this Razor Page application. No one else is going to write into it or make use of it except for this Razor Page application that is writing into it and is reading from it. Therefore, the life cycle of these two are together, and therefore I can put these two at the same time. Now when I say the life cycle is together, it doesn't mean that if I decommission this application I'm going to destroy this database. Remember, in the previous videos, we made a persistent volume, and our Postgres database is persisted, so that even when we destroy this Postgres database here, it is persistent in the Azure disk, and we still have access to the Azure disk. Okay, and now I'm going to show this, because for example right now you see that basically this is working. I can see the categories, I can add the stuff here, etc., and also I can have products, and I can see the list of all the products that are here. For example, let me add something like, for example, I say sofa, and sofa is basically a furniture. Okay, so now it's working. Now I'm going to show you that I'm going to delete this infrastructure, and with one command I'm going to recreate the whole infrastructure. So basically the Postgres and basically the Razor Page application. Because of that, I'm going to basically show you that really the database is not being destroyed. the Postgres is destroyed, but everything is already persistent in the Azure disk thanks to the persistent volume claim. So here I have put one command here to see that all the Helm charts that we have in place. So right now we have this .NET application. So sorry, this is the namespace. Basically, where is it? Full app. This is the one that we have here right now, full app. So, and I have, as I mentioned, I have explained everything in the documentation. I am going to show you that everything right now is in place. kubectl get all -n, and basically it was .NET application. .NET application, if I can type it correctly. So here you see that basically you have a Postgres database which is in running status. You have the Razor Page application. The Postgres pod is coming from the StatefulSet. That's why it's following a specific naming convention, unlike the one that is coming from the Razor app, which is coming from a deployment. And in deployment, whenever you have a replica set, some alphanumeric value is appended to it, and then to the pod, some alphanumeric value is appended to the replica set name. And then we have a cluster IP service that we already have seen that in the first video. It has been explained completely what a cluster IP is. Basically, cluster IP is a service that is abstracting away this pod, and it is only available from within the cluster. And then we have another one which is a load balancer service, which is a layer on top of this pod in order to make it publicly available, and that's why this one has an external IP. It's listening on port 80, while our application is in the container is listening on port 330. So basically this is it. With this, I am going to uninstall this full app. Basically, by uninstalling the full app, everything. I mean, let me show you before I do this. So, for example, if I say kubectl get PV, you can see that, for example, I have a persistent volume, and this persistent volume is of type read write once. It is retained, so that means when we destroy things, it's still going to keep the database itself, which is basically saved on the Azure disk. And then if I say, for example, persistent volume claim, which is in this namespace, you see that yes, we have a persistent volume claim that is already bounded to this persistent volume that we saw here, basically here. And you see that yeah, you can also see it here as well, that this persistent volume has already been claimed. So you can see it from both the persistent volume and the persistent volume claim. So everything is already in place. So for example, if I say kubectl get config map, and then which is also in the .NET application, you can see that, for example, the persistent volume claim for Postgres EMS is also there, etc. Now I'm going to uninstall this application, and I showed you that, okay, you can see that we already have this Helm chart, basically full app. So with that, I'm going to uninstall it, Helm uninstall, and the name is full app, and it is in basically .NET application. So let's see, get all the resources to see that it is destroying everything. Only the load balancer has remained. It takes some time to remove it as well. Let's have a look. Still there. It's being destroyed. And right now, of course, we cannot reach our application anymore because everything has been destroyed, including this IP. So because this IP has been created because of the load balancer, because of the service of type load balancer, but now that it is not in place, you see that it's not going to open it. Yeah, in the meantime, let's have a look. I think right now everything has been destroyed. Exactly, everything has been destroyed, and you see that the site cannot be is not reachable anymore. Okay, now that everything has been destroyed, we can go ahead and install Helm. install the whole full app, and basically this is what I told you. App stack is the one that contains, is the umbrella chart that contains the subcharts. I showed you that you can put everything that has the same life cycle needs to be together, and then we saw the values and the charts themselves, and now here I put it here, and then let's see how it creates the stuff. It didn't give any error, so that's basically it's working. Before running this, I have done Helm template app stack in order to see that everything is created successfully. So always check that before you run it with Helm installed. Now let's have a look to see that what is happening. You see, talking about dependency, I'm going to show you that why it's behaving correctly. You see right now the Postgres is running, and now that the Postgres is running, the Razor page app is going to be created. This is something very important and useful, and this is basically what I mean by dependency, and I'm going to explain to you what dependency means and why this is important. Let's see if it has been done. Yes, exactly. You see that now we have an external IP, and also we see that both of them are running. Remember, we destroyed the pod for Postgres, we destroyed the pod for our Razor page application, but we had a database, and the database had values inside it, right? So let's go ahead and have a look to see that if that database is still in place and is working. Let's have a look at our application. Okay, it found our application, view categories. And you see that everything is in place. Return to home, view products, you see that everything is in place. So for example, if I say go ahead and create a new product, I call it armchair, and then I can say that this is also a furniture, save, and you see that it has been added. Return to home, view categories, I can go ahead and create a category, and I can call it, for example, musical instrument, and here I see that it has been added. So as you see, as expected, by destroying a pod, by destroying all the resources, our database has been persisted. That was not the main point of this video. The main point of this video is that we can have a parent chart, and the parent chart is going to keep everything in place. So yeah, this is one point. Another thing that we can see is that kubectl pod delete. So let's go ahead and see that this is the great thing about Kubernetes. We can have basically we can go ahead and destroy these pods. So of course we don't want to do it, but if for whatever reason the pods gets destroyed, because we have a stateful set in the case of our Postgres, and we have a deployment in the case of our Razor page application, and they have defined the number of replicas that we want to have, it always, Kubernetes itself is going to check and see that if a pod is deleted, it goes ahead and start it immediately. So now let's have a look at this one. So I'm going to delete my pod, which is for my Postgres, and .NET application. Okay, this time I typed it correctly. Kubectl, I think maybe it is delete pod. I always make a mistake here. Kubectl delete, and then I guess it's delete pod rather than pod delete. And now let's have a look. Okay, the pod is deleted, and okay, the pod is deleted, and now let's have a look. You see, despite the fact I deleted it, immediately it created that, so nothing happens. And let me see if I can go ahead and really quickly delete this pod, and then let's see, for example, if we can see the application. So if I say create new category, no, still it is so fast that it really checks, and still it is in place. You see, it is in ready status. That's great. Okay, so if I go to home, okay, it's still working. Good. It shows me an error. It shows me an error because you see it is destroyed. It is in init status. And if I say, okay, go ahead and let's see. Okay, now it is running again. Because it's running again, if I refresh it again, everything is in place. And you see that everything, the last thing we added was musical instruments, was in place, and also the products, the last thing we add an armchair, it is also in place. So exactly as we expected. Or for example, if I go ahead and delete this other pod, so kubectl delete pod, and basically this time I go ahead and delete the pod for my basically Razor page application. Okay, and if I refresh it, so again it has recreated it very fast. So you see, how do we know that it has recreated it very fast? See, the name of it before was RxH at the end, but the new one's name is T5D. So it has created everything and everything is in place. So that's one thing. One thing I mentioned that was very important. Let me go ahead and basically do Helm uninstall and full app, basically full app. So Helm uninstall, what is it? Helm, basically dash n, it is in .NET application. Okay, so let me go ahead and delete everything. So right now, because I want to show something again, it takes some time to delete everything. I told you one thing is very important. Our Razor page application basically depends on the Postgres database. Remember, we have this code, and basically in our program CS, you see that we at some point we need to add the DB context, and in the DB context we need to mention that where to, in what connection string it needs to use. Basically, our application will not work unless it has a successful connection to the basically to the database, and the database has already been defined here. Basically, I think in the first video I have explained, this is the name of the service. Postgres service is the name of the service that we have defined. You can find it here. Look at our Postgres, basically where is it? This is the app stack, and if I go to Postgres into service, here you see that this is the name, values the service.metadata.name, which you can find here on the Postgres, basically not here, here on the parent-child service. If I come here, you can find it here, Postgres service, right? So have a look at here. Postgres service is the name of the service. It is in this namespace .NET application. It is of type service, of type cluster IP, and it is listening on port 5432. And this is the name of the database we give it, and then we give it some username password. The values should not be here like this, the username password. But this video is not about DevOps engineering. This one is about purely how to deploy resources into Kubernetes. Therefore, I will maybe in another video I will talk about this, that what you need to put, what you need to do with them. So they need to be saved as environment secrets inside our GitHub workflows, inside our GitHub settings, or if you're using Azure DevOps, you need to use environment variables there and then save them as secrets there and make use of it there. So, but the most important thing is that the application will not work unless you have a working Postgres database. So basically, the point is Postgres subchart must be created first, and only when Postgres subchart is up and running, application chart needs to be created. How Helm is handling this? Well, Helm has a very simple mechanism. In Chart, what Helm does is that it goes ahead and starts creating them in order, but that asynchronously, and that is the tricky part. That means Helm comes to the dependencies and says Postgres. So Helm knows that it needs to go for Postgres and start creating this chart first. And after that, it goes ahead and creates application. But the point is, Helm doesn't wait until Postgres creation is done successfully, then go ahead and create the application. And that is a problem, because for example, imagine that you're using, for example, Kafka, and then for example your Kafka service is up and running, and then for example or your Kafka service is not up and running, but then you have some application that starts sending messages to your Kafka, but because your Kafka is not up and running, your messages are not even dead letter queued, but they're just lost. So you need to make sure that your application comes up only after Kafka is up and running. So that's the most important part here. And this is exactly the case for our application. I mean, in our case, it is not crucial because our application will just show error and will not work. But the point is, in some other cases, like the Kafka case I told you, messages will be really lost. They will not even be dead letter queued because there is no Kafka in place. So we need to make sure that the dependencies are followed successfully and they are being respected. And because Helm is creating everything asynchronously, it will not be able to enforce this. What is the solution? The solution is not with Helm. The solution is with using initContainers. How do we do that? Basically, in our deployment, in our containers, we need to add another container. So this is the init container. So with init container, I can show you exactly what it's going to do. I am saying that make a busy box. If you look at our values.yaml, I have put it actually into the parent's child, values.yaml. Here I have added an init container. I am saying that go ahead and create a new container. Call this container wait for Postgres. The purpose of this container is to make sure to wait until Postgres is running. And after Postgres service is running, init container is terminated successfully, and only after that the Razor Page application container is going to start being created. In init container, I'm making use of busybox. I give it a name, and then I say, okay, make a shell command, and in that run this command. This command is basically like netstat is trying to check if Postgres is really running by sending a request to Postgres, and after this Postgres service returns a result, it will, until it returns something, it will go ahead and keep doing it. And then it says echo waiting for Postgres, sleep for 20 seconds, and then again try again to make sure until it gets a result. Only after it gets results, this init container is terminated successfully, and then the container goes ahead and create the Razor Page application. So this is the point. Helm doesn't have any mechanism in order to enforce dependencies. The only way to make this dependency, maybe there are other ways, but at least this is one good way that I know, is to make use of these init containers. Let me show you that how the final, basically the final code looks like. So I can say Helm template app stack. Let me find it here. Basically, this is the StatefulSet, and this is exactly the one that I was after. So basically, this is the one. So let me show you something here. I can say deployment.yaml, and let's have a look at the deployment.yaml to see that what it creates. So I wonder why it didn't recognize everything. So basically, this is it. Did I write it correctly? Deployment.yaml. Okay, so it's because of a comma, that's why. Alright, so here it is. Look at the deployment YAML. So always, as I told you, before you run Helm install, always check to make sure that it is correct, or you can do dry run, but I always do Helm template to see that everything is really indented correctly, etc., so that my Helm install can run successfully. So you see under a spec we have init containers, and it says busybox, and then it writes a shell command. It writes a couple of commands, executes a couple of commands. The command that is important for me is this one, netstat for Postgres service on port 5432, and if it's not responding, wait 20 seconds and then repeat it until you get results, and after that the container is going to execute, etc. And exactly this is what we wanted. I don't need this file anymore. I'm going to destroy it, and voila, that's it. So now let me show you that how this is really going to happen, and you can see that this application template is not going to be created unless Postgres pods is up and running. Now let me show you. I'm going to run the command again, and immediately I'm going to say kubectl get all -n .NET application. Let's have a look. You see that none of them is ready. This is in init status. This is also in init. They are in this part. So basically our Postgres also has an init container. That one is running. Let me show you again. Still in init, all good. Okay, now this one is running. This one is still in init status. So you see that this one was quite easy to run. You see, and if I hadn't made this dependency, it would have first created and would be in error status, and this one would be impending until it gets into running. But now the Postgres is running. Now that the Postgres is running, this one is going to be created, and now both of them are running. The reason I put 20 seconds was to make sure that you can see this. You can see that this one is going to running and this one is still in init status. And now you see that everything is created, and here is my basically IP address, and with that I can go ahead and put it here, and you can see that the page is going to work again. Voila. And view categories, here we have musical instruments, return to home, view products, create a product, I give it piano, for example, piano, and then I can add musical instrument. And yeah, musical instrument, save, and it has been added. So yes, exactly. So basically, conclusion, whenever you have charts that have the same life cycle, put them together under the same parent chart. So because we are working on microservice bases, the database is only being used by the application, by this specific application, and their life cycles are the same. Therefore, I'm putting them both under the same chart. The other thing is that you need to mention the dependencies of the charts under dependency part, and the order of the dependencies is important. But the point, the caveat is, Helm is only creating them asynchronously. So first it goes ahead and creates the Postgres, and after that it sends another signal to create application, and that's why still the application can get into error status. The other thing is to make sure that the application is created after Postgres is by making use of init containers. So in your deployment you can go ahead and add an init container. In the init container you go ahead and basically run the command to make sure that it checks if the service is up and running. So it checks the service with its name and its port, and if it is not up and running, it waits for 20 seconds. We don't need to wait for 20 seconds anymore. It waits for 2 seconds, and then it tries again until everything is working and running. So basically that's how you implement the dependency, by going into the Kubernetes resource itself. Chart has, as I told you, Helm has limitations here because it creates everything asynchronously. And the third thing is that the parent values.yaml has priority over the child values.yaml, and parent values.yaml overrides values.yaml values if they both share the same values. If in like our case, our child's values.yaml has resources that parents doesn't have, the integration of both of them are being used in order to create the chart. And then about the structure for each of the charts, we need to add one section in our values.yaml, and we put all the dependencies below it. That's also about the subcharts, about values, and about the chart dependencies, and how to enforce it in the Kubernetes resource itself. That's the end of the video. So we saw how to create everything by using the Kubernetes API and the Kubernetes resources directly, which is the scenario 1. You can see that in the source code. Scenario 2, separate Helm charts. We saw that in the previous video, and in this video we saw that by using basically a parent or an umbrella Helm chart. In the next video I will talk about other scenarios, but not about Helm itself, but maybe about how to set up basically some encrypt basically certificate issuer, like for example Let's Encrypt. So thanks for watching. If you find this video useful, please subscribe and like, and if you have any questions, feel free to put it in the comments. I will get back to you as soon as possible. Thank you. Bye bye.